Here we go with 5.08. We're going to apply the formula for the sum of a finite geometric series. What we've learned so far, we've really not applied to real-world situations yet, and what we want to do is start looking at some real-world scenarios in which it would be helpful for us to find the partial sum of a geometric series. So let's just start off reminding ourselves what is a partial sum, right? So the partial sum, S sub n, of a finite geometric series is going to be the sum from the first term to the nth term of the sequence, right? And what we want to remind ourselves of is what exactly this a sub I is. Well, that's each term in the sequence, right? And so in a geometric sequence, what we have is that we are starting with a sub 1, and what we're doing is we're multiplying it by some common ratio a certain number of times, n minus 1 times. All right, so that's what each a sub I is going to look like. And so the way that we can then define this is that this is the sum I equals 1 to n a sub 1 times r to the I minus 1. Right? And if you think about this, this is just going to be each term in the sequence, right? When I is 1, we have a sub 1 times r to the 0, which is 1, so that's the first term, right? So if I were to actually write this out, the sum, I would start with a sub 1, then I would have a sub 1 times r, a sub 1 r squared, and I'm going to add, continuing, going all the way out until I is equivalent to n, where I'm going to have a sub 1 r to the n minus 1. Right? That's going to be the last term of my sequence. And what we discovered is that you can compute the partial sum without having to compute n different terms with a closed form, a much easier equation. Just like that. Right? And there's an alternative form too, which I will write as well. Sometimes it's easier to write it this way. A sub 1, 1 minus r to the n over 1 minus r. Either one is going to get you where you need to go. Okay? And for both of these, what can't r be? Right? Well, when we go through and we actually manipulate this, we're multiplying by r minus 1. And so if r were to be 1, we'd end up with an undefined statement. So this is as long as r is not equal to 1. Okay. So now we're going to think about applying these in situations where the real world scenario requires us to find the partial sum of a geometric sequence. Right, so during a 31-day long month, such as March, you are given the following: $1 on day 1, and then $1.10 on the second day, so on and so forth. Each day you are given 10% more than you were given the day before. Part A, how much would you have after 31 days? And then Part B, what would the percentage need to be so that you'd make $1,500 by the end of the month? So pause the video here and separate your paper into two sections. And on the left section, I want you to give this a try on your own. It might be helpful to just write out maybe what you'd have on day 1, how much you'd get day 2, day 3, maybe go up to day 4, just to give yourself a little idea of what's happening, and then go ahead and go from there. Make sure you give it a full attempt, and then we'll talk about this one briefly. Right, so if you think about it, on day 1, let's make a quick little chart here. So on day 1, you'll get $1. On day 2, you will get $1.10. On day 3, you will get 10% of that, which is $1.21. Day 4, you're just multiplying by another 1.1, and that's going to give you $1.33. And so you can see, how do you get from one to the other? Well, you multiply by 1.1 each time, and remember that 1.1 is going to allow you to keep the original amount that you have at the end of this month and add the 10% to that so that you get $1.21. So how much will you have after 31 days? Well, what we want to do here is we want to add the amount that I'm given each day. So what I'm looking for is the partial sum up to day 31, or when n is 31. And so, of course, what this is doing is saying take the sum from 1 to 31 of each term. And each term is given by a sub 1, I'll plug that value in a second, times r, the amount that I'm multiplying by, to the I minus 1. And of course, a sub 1 is just $1. That's the amount I start with. And r is the common multiplier, which is 1.1. So we know what this will be equivalent to. It's going to be a sub 1, which is 1, times r, 1.1, to the n, which is 31, minus 1, divided by r minus 1, which is 1.1 minus 1. So S sub 31 is going to be equivalent to $181.94. $181.94. All right, excellent. Now for part B, what we're being asked is what would the percentage need to be so that you would make $1,500 by the end of the month? So in reading this question and you think about what is the percentage, well, the percentage is related to the multiplier, right? When I multiply by 1.1, I'm increasing by 10% every time. So here what I need to find is I need to solve for r so that the total amount that I get by the end is 1,500. And this total amount is just the partial sum. So this is the value that you want S sub 31 to be, and you need to figure out what the R value must be so that that happens. Now there are a couple ways that we could do this, and the first thing you want to just think about is what is S sub 31? Well, S sub 31 is equivalent to, how do we calculate it? Well, you take the R value, raise it to the 31st power, subtract 1, and divide by R minus 1. And you want this to be equivalent to 1,500. Now, there are a couple ways to do this. And what I encourage you to do is pause the video right now and just imagine you're on a test and you need to figure out how to find the R value that will make this work. You can use a calculator, you can use Wolfram Alpha, but pause the video now and go ahead and give that a try. So there are a couple ways to do this. The first is to just recognize that we could try different R values. You know it's going to be greater than 1.1 because when the R value is 1.1, you made $181.94. So knowing that, you might try a bigger value. Maybe you try 1.3. Well, if you try 1.3, you'll find that you get too big of a value. So maybe you go and you try 1.2. And when you try 1.2, you'll find that you get very, very, very close. You could go through and try and solve for R here, and what you're going to end up with is a 31-degree polynomial, and you might set that equal to 0. So let me kind of walk you through how that would work. You'd multiply by R minus 1 on both sides, and you'd have R to the 31 minus 1 is equal to 1,500 R minus 1,500. 1500. And now you have this 31-degree polynomial here, and what you might think about is, well, if I set the polynomial equal to 0, then I could, sketch a graph of it, or, graph the function and see where it intersects the x-axis. And so in doing that, you'd end up subtracting and adding to both sides. And when you do that, move this way over here, you'll end up with r to the 31st power minus 1500 r plus 1499. And that would be equal to 0. And then you could go and you could graph this equation and you could see where it intersects the x-axis. And what you're going to find is that this is when r is approximately 1.2. So going back to the question, an r value of 1.2, how is that increasing your total each month? So the percentage, well, you're multiplying by 1.2 to get from one step to the next. And so remember, the 1 multiplying by 1 keeps the same value that you had from the day before, and then multiplying by 0.2 will add 20%. So the percentage that you'd need to get to $1,500 would be about 20%. So before email made it easy to contact many people quickly, groups used telephone trees to pass news along to members. So in one particular group, each person is in charge of calling 3 people. So it starts off, one person calls 3 people, and then each of those people will call 3 more people, and the pattern continues in that way. So how many people have the news by the end of the fifth stage? Find the total number of people in a phone tree that has 10 stages, and then how many stages are required to cover a group of 1,000 people. So go ahead and just pause the video now and try and map out the number of people that receive the news at each step of the way. So let's just kind of think about each step of the way. So the first step, the first stage, if you will, one person has the news. Then in the second stage, how many more people get the news? Well, 3 new people get the news. In the third stage, how many new people get the news? Well, each of those 3 people calls 3 more people, so that would be 9 people who get the news. So this is the number of people each step of the way that is receiving the news. So after 3 hours, the total number of people that have the news is going to be 1 plus 3 plus 9, or 13 people. Okay. All right, so using that, go ahead and answer A, B, and C as a part of your comment. So your comment that you leave should have 2 things. It should have a question that you have, and then I also want you to include your answer from part B. Part B. Okay, so include your answer from part B and have a question of your own, or of course this could be an answer for someone else. But don't forget your answer to part B as well, so both of them.